Hello everyone, welcome to my channel strongmath. Today in this video we will discuss about some important functions such as constant function, identity function, polynomial function, modulus function, signum function, box function, etc. So keep watching this video till the end, don't skip the video. At first, constant function. The function f maps real number r to set of real numbers r is defined by y equals to f of x equals to c for all x belongs to R. Here capital R is denoted by the real number, where C is a constant and each x belongs to R. So what is constant function? For every values of x, that is for every real numbers, if the function gives us the same value C, where C is constant. For example, you may choose f of x equals to 2 for all x belongs to real numbers. So for all the reals, if the function gives us the same value 2, then the function is known as constant function. So what is the domain of this function? Clearly we know that the first set is said to be the domain and the second set is said to be the codomain. So domain of this function is R, that is set of real numbers, and the range is C, the constant. Why? If we draw two sets, this is domain set, this is codomain set, okay, this is codomain. Now suppose they are negative reals, 0 positive reals. Now for all the values, the points will map to a particular point C. For all the values, there are so many points left in the codomain set also. So in this case, range is the singleton set C. Let's draw the diagram of constant function. Look, this is x o x dash axis, this is y o y dash axis. The function, let us choose this function f of x equals to 2. That is, for 0 the value of this function will be 2, for 1 the value will be 2, for 2 this will be 2, for 3 this will be 2. Similarly negative 1 the value will be 2, negative 2 value will be 2, negative 3 value will be 2. So for all the integer parts as well as the fractional parts, the values of the function will be 2. Therefore, the graph of this function will be f of x equals to 2, that is y equals to 2, which is parallel to x axis. So remember, the graph of the constant function will be a straight line parallel to x axis. So clearly the graph of a constant function is a straight line parallel to x axis. Next, identity function. The function f maps R to R defined by y equals to f of x equals to x, that is y equals to x, simply y equals to x for each x belongs to R is said to be the identity function. That is, here the values of x coordinate and the y coordinate are equal. So the coordinates will be xx or yy, right? The domain of the identity function, clearly the first set. So set of reals is the domain. What will be the range of this function? Clearly the real numbers are the range of this function also, because here the values of x and y are equal. So range and domain are also equal. So let us take x o x axis and y o y axis as the Cartesian axis. Here the coordinates are given along the axis. Now what will be the graph of y equals to x? If we take 0, then y is also 0. If we take x equals to 1, then y will be 1. If we take x equals to 2, then value of y is also true. If x equals to 3, y is 3. So clearly we will get the graph of the function y equals to x as a straight line passing through the origin and which makes an angle 45 degree with respect to the positive direction of x-axis. So, the graph of y equals to x gives us a straight line making an angle 45 degree with respect to positive direction of x-axis. The line is passing through the origin, that is 0, 0. Next, polynomial function. A function f maps R to R is said to be polynomial function if for each x belongs to R, y equals to f of x is equals to a0 plus a1x plus a2x square plus up to an x to the power n, where n is non-negative integer and for all ai belongs to R. That is, a function is said to be polynomial function if we can represent it by a polynomial. Here look, the degree of the polynomial is n. So degree of the function will be according as the degree of the polynomial. Okay, and n will be the non-negative integer. For example, f of x equals to 5x cube minus 2x square plus 2. This is an example of polynomial function. Another example of polynomial function is g of x equals to 3x square plus 2x. These two are polynomial functions. Now clearly the domain of the polynomial function will be real numbers in general, and also the range of the polynomial function will be the real number. The domain or range may vary with respect to the polynomial. An example of polynomial function, f of x equals to x square. So its domain will be real number. Range, let's see what will be the range of this function. Suppose if we choose any two sets, this is a set of real numbers. Suppose this is negative real numbers, this is 0 and this is positive real number. Similarly, negative reals 0 and positive reals. Now f of x equals to x square. So if we take minus 1, x equals to minus 1, then x square is equals to minus 1 square equals to 1. Similarly, if we take x equals to minus 2, then x square equals to minus 2 square is equals to 4, and so on. So it is clear that all the negative real numbers will map into the positive reals. Now if we take the positive reals, then it will gives us the positive numbers. Okay, and if we take the 0, then 0 square is 0. So it is clear that all the negative reals will map to the positive reals, right? 0 will map to 0 and all the positive reals will map to positive reals, right? So it is clear that there is no pre-image of the negative reals of the codomain set. So what will be the range set? We know that the range set or image set is known as those elements which has pre-image in the domain set. So this is our range set for this function. So clearly the range set will be positive reals union the singleton set 0. This is the image set or range set of this function y equals to x square. Now what will be the graph of this function? The graph of y equals to x square will be like this. This is y equals to x square. Look, this will meet at x axis at 0, 0 point. For x equals to 0, y is also 0. You know that this is a diagram of parabola. Now by the graph we can easily find out the domain and range of a function. How? Look, for domain we will take the x-axis. All the points from the x-axis will gives us the domain of a function. Since we know that on real number line we can plot every real number, as well as for every real number there is a unique point on the number line. Okay, so for domain we choose the points from x axis. So you may call it the x axis as the domain axis also. For range we will get the points from the real y axis. So y axis will give us the range set. You may consider y axis as the range axis. Look, domain is all the real numbers, correct, and the range is positive reals. Upper half of the y axis is positive, we know that, positive, and the range is positive reals with 0. Look, this graph lie on the upper half of the y axis, right, including the 0. So clearly you can easily find out the domain and range from a graph of a given function. Let us consider the function f maps R to R, where f of x equals to x cube. Domain of this function will be the set of real numbers. What will be the range? We will discuss later. Let us draw the diagram or graph of this function. Look, if we plot the numbers, then suppose this is x, this is y. For 1, the value of y is also 1. For 2, 2 cube is 8. For 3, this will be 27. Similarly, for minus 1, this will be minus 1. Minus 2, this will be minus 8. Minus 3, this will be minus 27, and so on. So if we plot the points, then for 0 this will be 0, for 1 this will be 1, for minus 1 this will be minus 1 also, for 2 this will be 8, for 2 this minus 2 this will be minus 8, for 3 this will be 27, for 4 this will be 64, and so on. So clearly you can easily plot the graph of y equals to x cube like this. This is y equals to x cube. This function is increasing very steadily in the upper half of x axis, and the lower half of x axis this function is decreasing steadily. So clearly from the graph of this function the range is also set of real numbers. Okay, the next function is y equals to f of x equals to 1 upon x. Now the function is defined on the real number to real number, but here the function is equals to 1 upon x, reciprocal of x. So you have to redefine the function as f maps r minus 0 to r. Why? For x equals to 0, f of x is not real. Clear? So clearly the domain of this function is real number minus 0, that is non-zero real numbers, and the range of this function is equals to the set of real numbers. If we draw the graph of this function, then the graph of this function will be like this. This is the graph of y equals to 1 upon x. Let us discuss the most important function of today's topic, that is modulus function. The function f maps R to R, where y equals to f of x is equals to mod x. So we write mod x like this, where x is a real number, is called the modulus function, and the function is defined as follows: f of x equals to mod of x is equals to x when x is positive. The value of mod x is 0 when x is 0, and the value of mod x is minus x when x is negative. This is the definition of modulus function. This is very important function. You have to remember this function and its definition as well as its graph. So roughly if we draw two sets, this is set of real numbers, this is set of real. What will be the domain of this function? Domain will be set of real numbers. What will be the range of this function? Let's discuss. So clearly here, this is the set of all negative real numbers, this is 0. This is set of all positive real numbers. Similarly, we can write negative reals 0 and positive reals in separate form for the codomain set. If x is greater than 0, then mod x is x, that is x is also positive. So all the positive reals will go to the positive reals of the codomain set. Clear? For 0, the value will be 0. This will also go to 0. Now if x is negative, what will happen? X is negative means take x equals to minus 2. Then mod of minus 2 will be, by definition, here x is minus 2, which is negative. So value will be minus x. So minus x. What is the value of x? X is minus 2. So this will be plus 2. Mod of something will gives us the positive value only. Why it will give always a positive value? This is the reason for getting the positive values of mod x. So if we choose positive 2, then by this definition, positive 2 plus 2 or positive 2 will lie in this condition. If x is greater than 0, then mod x is x. So here x is greater than 0, so value will be x. What is x? X is 2 here, so this will be 2. If we take minus 3, mod of minus 3. Now look, minus 3 is negative. By definition of mod x, this will gives us a minus sign outside and the x. What is our x? In this case, x is minus 3. So this is positive 3. So it is clear to you that the negative numbers of the domain set will map with the positive real numbers. So clearly the range of modulus function is the positive reals with the singleton set 0. Now let us draw the graph of this function. At first look, if x is positive, mod x is x. So for the positive values of x, that is positive side of x axis, will gives us the function as y equals to x, where x is greater than 0, y equals to 0 for x equals to 0, and y equals to minus x for x less than 0. We have already learnt about y equals to x. Okay, so the graph of this function, we know that for the value of 1 we will get the value of y as 1 also. For 2 we will get 2. For 3 the value of y is also 3. So clearly the graph will be like this. Clear? So for x is greater than 0, mod x is x. Now if we take the negative x, then value of y will be minus x. For minus 1, the value will be positive 1. This will be y equals to minus x. Okay, so this is the graph of modulus function. Let us elaborate the modulus function. How? Suppose there is mod of x minus 2, then what will be the value of mod of x minus 2? Okay, so mod of x minus 2, this equals to, what is the definition of mod x? Mod x is equals to x for x is greater than 0. So mod of x minus 2 will be x minus 2 for x minus 2 greater than 0. Just replace x by x minus 2. We have to replace x in the definition of mod x by x minus 2. Okay. So this is 0 for x equals to 0 and negative x for x is negative. So clearly this will be 0 if x minus 2 is equals to 0. This will be negative x minus 2 if x minus 2 is negative, right? So ultimate definition or ultimate value of x minus 2 will be, value of mod x minus 2 is x minus 2 when x is greater than 2 if we take minus 2 in the right hand side of the inequality, right? This is 0 if x is equals to 2. This is 2 minus x, multiplying minus sign with the x minus 2 if x is minus 2. So if you are given mod of x plus 3, what will be the value? You can easily write the values of the function. This is x plus 3 when x is greater than minus 3. This is 0 when x is equals to minus 3. This is minus x plus 3 if x is less than minus 3. Okay. Just remember the definition of mod x. Then you can easily find out all the values of any kind of modulus function. Let us discuss another important function which is known as Signum function. The function f maps are toward where y equals to fx equals to sgn x. Sgn means Signum function. Signum function x is equals to modulus of x by x, where x belongs to R. So Signum function is mod x by x. Okay. So what will be the domain of this function? Domain will be set of all real numbers. Okay. What will be the range of this function? Let us discuss. At first, Signum function mod x by x. Look, if x is greater than 0, then modulus x gives us x. So x by x. If x is equals to 0, the Signum function is defined as 0. Okay. And if x is negative, then the value of mod x is minus x upon x equals to 1 when x is greater than 0. This is 0 when x is 0 and this is minus 1 when x is negative. This is the definition of Signum function. Don't mistake here. Here it is already defined when x is 0, then Signum function is 0. You may write this as Signum function Signum x equals to mod x by x when x is not equals to 0 and is 0 when x is 0. This is already defined like this. That is, when x is 0, then Signum function will be 0, and when x is not equals to 0, then Signum function will be mod x by x. This is already defined. So Signum function, that is mod x by x, gives us 1 when x is positive, minus 1 when x is negative, and 0 when x is 0. So clearly the range contains only 3 elements: 1, 0, minus 1. Look, for all the real numbers of x, we will get the constant function 1. Remember the constant function? For Signum function, if x is greater than 0, then y is equals to 1, right? We know the constant function is represented by a straight line which is parallel to x-axis. So clearly the graph of for this portion, that is positive half of x-axis, will get this line which is parallel to x-axis, and clearly here the point 0 is excluded. Why? Because for x equals to 0, value is 0. So for 0, the value will be 0. And for the negative half of the x-axis, that is for x less than 0, the value of y is equals to minus 1. Okay. So excluding the point 0, that is here already it is defined that for 0, the value of y is also 0. So the graph of y equals to minus 1 will be parallel to x axis and it is a straight line. Clear? So this is the graph of Signum function. Now let's move on to the most important function, box function, which is known as greatest integer function or least integer function. The box function is defined by the function f maps R2R where y equals to f of x equals to in brackets x, where x is real number. Assume the value of the nearest integer less than or equals to x. This is the definition of box function. Let's explain about this line. Box of something will gives us the nearest integer which is less than that number. Now look, if we take box of 2.5, now on number line 2.5 lies in between 2 and 3, right? Now there are two nearest integer of 2.5 and they are 2 and 3, and which integer will be selected for box function? It is given that less than or equal to x. That is, we have to take the nearest integer which is less than the given value. Okay, so for 2.5 there are two nearest integers and they are 2 and 3, and among them, among 2 and 3, 2 is the smaller one. Okay, so for box 2.5 the value will be 2 only. Suppose if we choose minus 2.5, okay, then on the number line, look, minus 2.5 lies in between minus 2 and minus 3. This is minus 2.5. So nearest integers are minus 3 and minus 2. Which one is smaller? Minus 2? No, the smaller one is minus 3. For minus 2.5 this will be minus 3. Now try to understand very clearly and slowly. Look, if we take any numbers in between minus 3 and minus 2, including minus 3, in between minus 3 and minus 2 there are only fractions. Okay, and which number is lesser among minus 2 and minus 3? Minus 3. So if we choose any numbers including minus 3, if we take minus 3, then the value will be minus 3 clearly. Okay, so for minus 3 the value will be minus 3. Look, here in this range we are not taking the value for minus 2. So we are excluding the point minus 2. Okay. Now in between minus 3 and minus 2, suppose there is minus 2.5, then the box of minus 2.5 will be minus 3. So for all the fractions in between minus 3 and minus 2, the values will be minus 3, right? So for minus 3 to minus 2, the values will be minus 3. This point is included and this is excluded. Similarly, for the range minus 2 to minus 1, for minus 2 the value will be minus 2. The point is included here, but minus 1 is not included. So in between minus 1 and minus 2 the values will be minus 2. That is, box of x is equals to minus 2 in the range minus 2 less equals to x less than minus 1. Similarly, in the range minus 1 less equals to x less than 0, the value will be minus 1. This point is included and 0 point is excluded, and along this range the values will be minus 1. Clear? If we take 0 less equals to x less than 1, then the value will be 0, as 0 is less than 1. So this value will be 0. So for 0 the value will be 0. For this fraction value will be also 0. This fraction value will be also 0 up to nearest to 1, but excluding 1. So this value will be equals to 0. If we take the range 1 less equals to x less than 2, as 1 is less than 2, so value will be 1. So for all the fractions including 1 the value will be 1. excluding the point 2. Clear? Similarly, for the range 2 less equals to less than 3, the value will be 2. So for 2, the value will be 2. The point 2 is included. And for all the fractions in between 2 and 3, all the values will map with 2, right? But excluding the point 3. So look, this is the graph of box function. Look, it is in the form of stairs. So stairs or steps. So this function is also known as the step function. So box function, greatest integer function or step functions are all same. Domain of this function will be all the real numbers, right? And the range of this function, look, the range of this function gives us only the integers. So range of this function is the integers. Thanks for watching this video. Please like, share and comment, and obviously please do subscribe my channel Strong Math. Mention your query. Keep watching. Thank you.